The US has taken the spotlight once again. And guess what? It's not for its usual creation of exceptional fighters and carriers. Well, it is something related but significantly different. The world stands and watches in awe as this nation unveils its newly developed technology, an advanced engine which possesses the sheer power to propel the most feared fighters ever and is better than any propulsion system that has ever been created. What is this new innovation all about? What is the futuristic design that it offers the world of weaponry? Join us as we delve into the details of the fastest hypersonic missile that the United States just revealed. In the face of modern warfare and an evolution that has transformed and developed almost every sector, including the military, the United States is in the process of developing the most powerful fighter vehicle globally, and this technology would undoubtedly need the most formidable propulsion system. Just as you guessed, the US has also taken a full sprint in that direction as well. With renowned and experienced weapon companies that have devoted their time and efforts to building fighters that are advanced and equally stealthy, there is no doubt that the US would have to surpass these companies. Looking at the history of the United States in terms of development of futuristic designs, they just might be up to the task. Weapon manufacturers and American companies like Boeing, Northrop Grumman, and Lockheed Martin are involved in the unique project of aircraft development, while General Electric, Pratt & Whitney, Raytheon, and other significant entities are dedicated to advancing the propulsion technology around the clock. Pratt & Whitney is an American company that makes aeroplane engines and provides services worldwide. It's part of RTX Corporation. Their engines are used in both regular and military planes. They are the second largest producer of commercial aircraft engines globally, holding 35% of the market in 2020. Besides aircraft engines, they also create gas turbine engines for industries, marine use, and power generation. In 2017, they said they helped over 11,000 customers in 180 countries. The Pratt & Whitney PW1000G, also known as the GTF, or Geared Turbofan, is a type of advanced engine made by Pratt & Whitney. It began with the PW1200 on the Mitsubishi SpaceJet in 2008, but the project was later canceled. The first approved version was the PW1500 for the Airbus A220 in 2013. The whole program is estimated to have cost around $10 billion. But while the United States is keen on creating its own engine, the General Electric, whose propulsion system can be found in almost all the formidable fighters ever created, has already made waves in aviation territory. Definitely, the US innovation would stir up competition. Recently, this engine company announced that it has successfully demonstrated an advanced jet propulsion system that involves a dual-mode ramjet design that would make use of a rotating detonation combustion. This is a huge development that proves how capable General Electric is and how challenging it would be for the United States to surpass such a competition. In 1896, this company was among the first 12 companies on the new Dow Jones list, and it stayed on the list for more than 122 years, though not without breaks. This company is undoubtedly good at what it does. Under Sanford Alexander Moss's leadership, General Electric began the development of aircraft turbo superchargers, which later led to industrial gas turbine engines for power. They introduced the first superchargers during World War I, continued developing them between the wars, and supplied 300,000 for fighter and bomber engines in World War II. This experience positioned GE to develop the US's first jet engine during the war, and they played a role in the Whittle W1 jet engine. Even though early work was handed over to Allison Engine Company, GE Aviation became one of the world's largest engine manufacturers, surpassing Rolls-Royce plc. These ramjet engines, created by this formidable engine company, possess unique capabilities and are renowned as one of the few engine types capable of accelerating either jets or missiles to hypersonic speeds. One of the most unique features is the rotating detonation concept, which is used by detonation to make even the most powerful engines more powerful. Also, this engine company has found a solution to the major setback that ramjets face. Ramjets were designed to be extremely powerful and can only operate efficiently at super high speeds. If these engines fly at lower speeds, they perform worse off than weaker engines. This problem has been a major one to leap over for years, which prevented the United States from going into the development of hypersonic weapons. But General Electric already found a solution to it. General Electric's innovative engine design is different and better than the conventional system of rotating detonation and ramjet technologies by seamlessly integrating both, thereby leading to the birth of a sophisticated engine that is known as the rotating detonation ramjet. Originating in the 1950s, the pursuit of this technology lasted over 7 decades, promising remarkable efficiency by harnessing the potent force of detonation. These engines feature superior fuel efficiency and a simple component structure compared to their traditional counterparts, which makes them powerful. Consequently, a small-sized rotating detonation engine can rival the power output of a substantially larger traditional engine. This innovation is definitely a manifestation of engineering prowess and efficiency. On the other hand, pulse-jet engines work by mixing air and fuel within a combustion chamber and then lighting the mixture up to be shot out of a nozzle in rapid pulses, rather than under consistent combustion, as in jet engines today. The air and fuel mixture then burns away. These detonation engines make use of explosions rather than gentle deflagration, because detonation comes with significantly more energy and 20,000% faster shock waves than deflagration. This type of engine gives the aircraft more thrust from the same amount of fuel and ultimately a system that propels a vehicle to speeds up to Mach 5. Instead of the detonation shock wave traveling outwards through the back of the aircraft as propulsion, the waves travel around a circular channel within the engine itself, basically recycling the same thrust over and over again. And while extra fuel is added to recycle thrust, significantly less fuel is required to do so. In addition, this engine gives more efficient continuous thrust as opposed to the pulsing gapped thrust that pulse detonation offers. Engines based on rotating detonation alone would be able to thrust aircraft or missiles to high hypersonic speeds. Turbojet engines have a turbine and compressor and other mechanical parts that enable them to ignite fuel in slower-moving air and function effectively. In an interesting turn of events, turbojet engines began to lose their efficiency at speeds approaching Mach 3, around where ramjets and rotating detonation engines appear to find their voice. Combining a turbojet engine with rotating detonation engines would see the ramjet power the aircraft from a stationary position to about Mach 3, where the rotating detonation would then take charge and thrust the aircraft or missile to hypersonic speeds. This amalgamation is known as a turbine-based combined cycle engine, or TBCC engine. Powered by 2 Pratt & Whitney J58 engines, each producing 32,000 pounds of thrust, the Blackbird has a top speed of Mach 3.2 and an altitude of 85,000 feet, which forced Blackbird pilots to put on pressurized suits like astronauts do, because they were very nearly in space. Interestingly, this fighter had no weapons. It does not need them because when it gets fired at, the jet would simply outpace the missiles or bullet rounds shot at it. This explains why no Blackbird was ever shot down even after being in service for over 33 years. To this day, it holds the record for both the fastest and highest flying operational aircraft in history. In 2007, there were initial reports about the SR-72, a super-fast aeroplane developed by Lockheed Martin. It could fly 6 times the speed of sound for the Air Force. Details about its development were first revealed by Aviation Week and Space Technology on November 1, 2019, which led to a lot of public interest and overwhelming Aviation Week servers. Since 2006, Lockheed Martin had been working non-stop with Aerojet Rocketdyne to develop an engine for the formidable SR-72. They began with the HTV-3X project, which was canceled because they wanted a hypersonic propulsion system. They wanted to create an engine that would be able to handle subsonic, supersonic, and even hypersonic speeds. Regular turbojets engines perform efficiently when a jet flies up to a Mach 2.2, and ramjets work well when at a speed of Mach 3. When flying at Mach 5 and higher speeds, the intense heat can melt regular metal structures. To address this, engineers are thinking about using advanced materials like high-performance carbon, ceramic, and metal blends for important parts. Similar composites have been successfully used in intercontinental ballistic missiles and the now-retired Space Shuttle. These engines are designed to fly at specific speeds, but they needed something that could fly effectively and efficiently at different speeds. The jet was designed to perform intelligence, surveillance, and attack missions as of May 2015. But there were no specific details concerning the payloads, probably because the payload that were available were not enough for an aircraft that flies up to a height of 80,000 feet and needs extensive distances in order to change its direction. In order to achieve this, new sensors and weapons that are designed for such high speeds would need to be developed. The SR-72 was supposed to be around the same size as the SR-71, over 100 feet long, and have a similar range. It was planned to be in service by 2030, following the U.S. Air Force's plan for a hypersonic weapon by 2020 and a reconnaissance aircraft by 2030. When revealed, Lockheed Martin discussed the concept with officials, but there was lack of funds to pursue the project. The Air Force was interested in the SR-72's high speed for quicker operations. They were after the hypersonic tech, but they lacked the capability to build a full-size plane like the SR-72. Budget cuts led to the challenge of balancing Air Force capabilities, capacity, and readiness. Looking forward to exporting this advanced fighter jet to foreign countries by the mid-2020s, the Air Force planned to develop a new system that would include hypersonic ones. In 2013, the Air Force later decided not to fund the SR-72 and chose the Northrop Grumman RQ-180 stealth UAV for contested airspace ISR missions because they expected it to be a better option due to the fact that it is cheaper, faster, and less complex to develop. This development is definitely an achievement for an aircraft that retired over 2 decades ago. For years, no other aircraft came close to challenging these records until now, with the introduction of the SR-72. Son of Blackbird, the SR-72 compared to the Blackbird is more advanced and developed, equipped with what makes it a success when airborne and on missions. This fighter could easily serve as Lockheed Martin's offering for America's invincible 6th-generation NGAD fighter. In December 2014, NASA paid Lockheed Martin $800,000 to see if they could use regular jet engine tech for the SR-72 aircraft. The money was for a study to figure out if a special system, combining a normal jet engine with a unique kind of ramjet, could make the aircraft work. Earlier, NASA supported a study that said the aircraft could go really fast, up to Mach 7 with this special engine. This study is aimed at making aircrafts fly really fast. This research looks into making engines that are faster than regular ones, but not as fast as super-fast ones. If it works, NASA might test this special engine in a flying aircraft like the F-14. Aerojet Rocketdyne is helping with the development, and they plan to start building the SR-72 fast aircraft in 2018, with the first flight scheduled for 2023. The F-14 had its first flight on December 21, 1970, and was deployed in 1974 on the USS Enterprise, replacing the F-4 Phantom II. It served as the main fighter jet for the U.S. Navy in maritime air superiority, fleet defense, and reconnaissance until the 2000s. In the 1990s, it also gained the Lantirn system for night missions and started doing precision ground attacks. The Grumman F-14 Tomcat is a powerful American fighter jet designed for aircraft carriers. It's supersonic, has 2 engines, 2 seats, twin tails, and adjustable wings. The F-14 was created for the U.S. Navy after the F-111 project fell through. These fighters were developed based on experience from air combat against MiG fighters in the Vietnam War. The F-14A initially had two Pratt & Whitney TF-30 P412A turbofan engines, each providing 20,900 pounds of thrust, allowing the plane to reach a maximum speed of Mach 2.34. For maximum fuel efficiency during long patrol missions, the F-14 would often fly at a cruising speed. The engine's air inlets had movable ramps and bleed doors to handle various airflow needs from takeoff to supersonic speeds. Variable nozzles were added to the exhaust. Later F-14As had improved TF-30 P414 engines. Originally, the Navy planned to replace the TF-30 with Pratt & Whitney F-401, the naval version of the F-15's F-100 engine, but this idea was dropped due to cost and reliability issues. The TF-30 engine's performance faced criticism. The Secretary of the Navy in the 1980s, John Lehman, said to Congress that the TF-30 F-14 combo was one of the worst engine and airframe matches, calling the TF-30 a terrible engine. About 28% of F-14 accidents were blamed on the engine. Frequent turbine blade failures led to reinforcing the entire engine area to minimize damage. The engines were prone to compressor stalls, especially at high angles or rapid throttle changes above 30,000 feet, risking loss of control and severe oscillations. Launching missiles at specific altitudes could also cause compressor delay, leading to a system that temporarily blocks the intake ramp during launch to reduce engine power. The F-14 could now take off from carriers without needing an afterburner, which helps to save fuel. The F-110 engine was efficient, allowing the Tomcat to fly comfortably above 30,000 feet, improving range, survivability, and mission endurance. In an attack role, the F-14B and F-14D had 60% more striking range or 1/3 more time on station. The F-14B was in service during Desert Storm. With the TF-30 engine, the F-14 had a lower thrust-to-weight ratio compared to the F-15A. However, when upgraded with the F-110 engine, the F-14's thrust-to-weight ratio improved significantly. Despite this, both versions had the same top speed. In 1969, two F-14s with F-110 engines crashed due to afterburner failures. After the second crash, using an afterburner below 10,000 feet was prohibited until General Electric redesigned the afterburners, a process that took more than a year. The fighter that would serve as the center of America's air superiority for decades to come. An aircraft of such caliber must be fitted with the most advanced technologies the U.S. and its army of world-renowned defense contractors can concoct, including the ability to be invincible. Stealth is a technological advancement that's been here only one generation of fighters ago, but it's one that's here to stay. According to the Air Force's 2019 and 2020 Biennial Acquisition Report, the sixth-generation fighter would maximize stealth via an overall triangular shape, internally holding its payload and having no vertical stabilizers. It is the first fighter in history to be unveiled with such a revolutionary design. Vertical stabilizers had always been required to keep an aircraft airborne until the concept of active flow control came to life in the B-2 Spirit, the stealthiest aircraft to ever enter service. Active flow control uses computer brains on board to constantly adjust the flow around the aircraft to keep it airborne, similar to how birds fly. The result of this on an aircraft is unrivaled stealth, as the B-2 Spirit and the newer B-21 Raider have more than shown. It does come at a great fiscal cost, though, which somewhat explains why the B-2 Spirit is the most expensive aircraft in history. Why Congress has budgeted over $10 billion for the Air Force's NGAD program in less than a decade. And why the Navy requested $9 billion over 5 years to develop its own sixth-generation fighter. Due to this, the U.S. is invested in making a new fighter jet that can easily get better over time without needing a complete overhaul. It's like building an aircraft that can be upgraded as technology advances. So, this jet might become even more advanced. The new 6th-generation fighter will have the most updated systems to do its jobs better and more efficiently. Instead of putting radars on the outside, it will have smart skins built into its body. This makes it better at connecting with other planes, talking across the group, and being extremely good at sensing targets or friendly planes from really far away. Unlike the SR-71, this 6th-generation fighter will be equipped with an entire arsenal of weapons that will include guns, bombs, missiles, laser-directed energy weapons, electronic warfare systems, loyal wingmen, and so on. From weapons and sensors to an open architecture and stealth, the new 6th-generation jet will be packed with capabilities required to dominate tomorrow's skies. All of these features to be designed in the jet will be powered by a new propulsion system that offers more power and might than any of the engines that was produced before it. Fast aircraft that have the ability to fly for a long time would be a great addition to the US military. This is because Russia and China are getting stronger, and the US wants to make sure it stays safe and even stronger than its rival. It's a bit like what happened in the 1990s Cold War, when the US and the Soviet Union were in a big competition for power around the world. If the United States continues with its improved and sophisticated innovations, this developed nation would soon have no rival to compete with in the nearest future because it would own the most formidable military arsenal amongst all nations. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.